Law of definite proportions. Very important law which was proposed after law of conservation of mass, which gives you the information about the ratio of combination of masses of elements, what ratio the elements combine with each other, which made the scientists to work on balancing chemical equation very easily, framing the chemical reaction very easily. And this was the law behind these all particular things. Let us see what the law states to us. The law states that a given compound always contains same elements in fixed proportion by mass, irrespective of method of preparation. Again, if I say a compound always contains same elements in fixed proportions by mass, irrespective of method of preparation. Statement is very simple. Let us understand this with an example. Before going to example, who proposed this law of definite proportions? This was proposed by Joseph Prost in 1806. According to this law, if you consider water in three different ways, water in three different ways, what are the different types of water I will be taking? One is the water, I'll take rainwater. Okay. Another water, if I am taking drinking water or normally a tap water, let us take rather than drinking water. Okay, this is the water, rainwater I have taken. Tap water you take, tap water also is fine. Okay, so now in a chemical reaction, water is produced. Water in a chemical reaction, water produced in a chemical reaction. Let us take in a reaction, water in a reaction. So we had the rainwater, we had the tap water, and the water produced in a chemical reaction. Like acid base neutralization you do, you'll get water, or hydrogen and oxygen you combine, you get a H2O, that water you see. Now if you say in the rainwater, the formula, chemical formula of water remains H2O. Whether it is tap water, the formula remains H2O. In this also the formula remains same, H2O. But the basic point what we are trying to do, in H2O it has 2 grams of hydrogen combining with 16 grams of water, giving you 1:8 ratio of hydrogen and oxygen. They always present in 1:8 ratio. Even if you see the tap water, you get the same conclusion. The hydrogen and oxygen are present in the same ratio of 1:8. Even in the water which is produced in a chemical reaction, you see any compositionally you check, you will get hydrogen and oxygen will remain still in the same ratio. At the same time, in any of these experiments, if you find the percentage hydrogen, percentage oxygen, they remains the same. So the percentage hydrogen and oxygen remain same in all the three experiments. So my consideration here is I have taken rainwater, tap water, and water in a chemical reaction. Whether I have taken rainwater or tap water or water in a chemical reaction, if I compare the mass ratio of hydrogen is to mass ratio of oxygen, I always see they are in a combination of 1:8 ratio to each other, and the percentage of hydrogen, percentage of oxygen remains constant. So what can be the definition I can say? A compound always contains same elements. For example, here always contains hydrogen and oxygen in a fixed proportion by mass, 1:8 ratio by mass, and irrespective of the method of preparation. So I am not concerned whether I am talking about rainwater, a tap water, or water in a chemical reaction. It does not change. Proceeding forward, if I can take one example, sodium chloride is obtained by two ways. Direct combination of sodium and chlorine. If I take the first method, in this experiment I have taken 1.55 grams of sodium reacting with excess of chlorine, giving you 2.925 grams of sodium chloride. So what will be the mass of chlorine if I am taking? Mass of the chlorine will be 2.925 minus 1.15, which is equals to 1.775. Now if I am taking mass of sodium is to mass of chlorine, we'll get 1.15 is to 1.775. We get a product of 1.1 is to 1.54. If the same experiment, if I do in this way, neutralization of acid and base, so that where we are getting NaCl by neutralization process, HCl plus NaOH gives rise to NaCl plus water. So in this case also, chemically we are getting NaCl. 1.53 grams of sodium is reacted with water to get sodium hydroxide, which is then neutralized by HCl to get 3.9 grams of sodium chloride. So you know what is the mass of sodium. So what will be the mass of chlorine if you take mass of chlorine is equals to mass of sodium chloride, that is 3.9 minus mass of sodium 5.1.53, which will be equals to 2.37. So we got mass of chlorine as 2.37. So now we are going to take the mass ratio of sodium and chlorine. It ends up with 1.53 is to 2.37, which is again equals to 1 is to 1.54, which is exactly the same which is before. So this is called law of definite proportions.